AB is parallel to DC. A little bit more space. Now, when you mark your givens when you have parallel, suggestion to do is mark them up to figure out, well, where does the transversal happen? Oh, it happens there. So when you do that, you should notice that you have the alternate interior there and there. When you are given numbers in a diagram, use them. If you're not given numbers, don't make them up. Fairly simple. So I can do angle 1 congruent angle 4, because if two parallel lines are cut by a transversal, alternate interior angles are congruent. Okay? Go to my next given. AD is parallel BC. Same deal. Parallel lines, transversal. Gives you 3 and 2. Oh, sorry. Two parallel lines cut by a transversal. Alternate interior angles. Okay. You have two angles now, which means you have to find a side after the angles or a side between the angles. What do you have?
Between.
In between. So you have AC is congruent to AC because it's called good. Now there are 3 different ways we can write triangles out here, depending on how you write your, or I'm sorry, there's only one way to show that they're congruent, but there's 3 different ways to write the statement out. If I start at angle C, if I go CAD, if I say triangle CAD, I started with 1 tick mark, went to 2 tick marks and over. I'd have to go triangle ACB. And then why can I say those last 2 parts are congruent? Yeah, exactly. So both of those are going to be.
I think I was confused because of the opposite angles.
Yeah. Whenever you get those, steals all my markers. Whenever you get those, remember, take the diagram and just follow where the transversal happens, and then you know it makes it where they touch. And the same deal when it went this way and this way. When the transversal goes, as you draw that through, where they touch is where they make it.
Okay.
That's the easiest way to do it. Okay? And you said which one also? The 6th one? So that would have been the 6th one overall. So this is 3. Oh, I just said CP for both of them. But they would just CP for both of them. Which one is it then, Julie?
Oh wait, no, not 6. Wait, hold on.
What does it look like?
This one.
Yeah, the kite one, you have to change that letter around.
They want something. Maybe that's why I was confused.
Yeah, this should have said B. This should have said DCA.
Instead of BAD,
Yeah.
it said.
This should say DCA. It was a typo on my part. And you might have bolted before we caught it. That's all. And then Jaylee, same one from the notes from the day before. CPCTC is not too bad, is it?
Yeah.
What about it?
Like when you use it.
When you're done. You can only use it after you have triangles that are congruent. Once you have triangles that are congruent, then you can say all the corresponding parts within those triangles are also congruent. That's the only rule. So in order to show that, well, this is kind of a bad example, but in order to show in one that, like this one, if I wanted to see that angles B and D were the same, I would have to have gone through I'm not going to, excuse me. In order to show that those were going to be the same, you would have had to have gone through your givens. You were given this. You were given that information. You would then have to say that you had a reflexive side. Then all of a sudden you had two triangles, ABC and ADC, because of side, side, side. Since those two triangles are congruent, all of their corresponding parts are congruent. That's how you use it. Show the triangles first, and then you can jump to that corresponding part. Okay? So what I want to get at today then, it goes back to the equilateral and the isosceles triangle. So I want to make sure that we do a couple of notes on that before we get too far along. So let's look at what's left off with isosceles and equilateral triangles. Now, like I said earlier, I'm not giving you guys any proofs with this stuff, but these things come up a lot with algebra, and they come up a lot with, what do you call it, drawing pictures and stuff. There's only a few little definitions and things like that. One of the other things I wanted to remind you guys about is that this, the test, you guys have to have your calculator because there's algebra in it, okay? You gotta have a calculator on it. So, we all know that isosceles triangles, guys, we all know that isosceles triangles are triangles that have a pair of sides. We talked about that before when we had, our classifying the triangles by sides or by angles. So, we did this at the beginning of the chapter. Everybody knows that an isosceles triangle has two sets of sides that are congruent. Okay? That's the main idea. The other part of the isosceles triangle is this part in between. The angle that is in between, that X didn't show up very well. The angle between the two sides that are congruent is always called the vertex angle. So you've got your two sides that are congruent. The angle that's placed between them is called the vertex angle. Now remember, it doesn't necessarily always have to be at the top peak. My example here on the whiteboard, it could be off to the side. It's still the angle that's in between the two sides. Okay? That's still the vertex angle. The other thing about the isosceles triangle that we've discussed before also is that if you've got legs that are congruent, the two sides are looking at what are called base angles that are congruent. So when you have an isosceles triangle, if you know that the legs are the same, the angles that are looking at the legs are also the same. Okay? So you wind up with being able to do this one little if-then statement. If this, then this, or vice versa. If this, then that. It means the same thing. It's a biconditional statement. If your base angles are congruent, your legs are congruent. If your legs are congruent, your base angles are congruent. That's more important for when you get to proofs, but like I said, we're not doing those, so it's not a big deal. What's nice about this is that it'll help you in a diagram if you have to solve for x. Okay? Now, when we write out isosceles triangles, there are two ways that they can be written. And it's a very subtle difference that I think you'll be able to pick up on real quick. Can I do a clean one real quick? No, sorry. See, we get along better when you're smiling instead of rolling your eyes at me. All right. What's up? There's two ways to write out and show that you have an isosceles triangle. They're very subtle in what the differences are. The first one is to say that triangle ABC is an isosceles triangle. Great, yay. The other one is triangle XYZ is an isosceles triangle with angle Z as its vertex angle. One of those is a little bit more specific than the other. Which one do you think is more specific?
2.
Correct. Which means, where's your vertex angle in number 2? Z. So when we draw this, you have to be able to account for where the vertex angle is. If Z is my vertex angle, what are the two sides that have to be congruent then? If Z is the vertex angle, where are the two sides? Which one? XZ and YZ. Because it's telling you that Z is the vertex angle. Z is the angle between the two sides that are congruent. Now, depending on how you wrote it, I mean, you could have said that this was X, Y, and Z could have been on this side. You could have said X, Y, and Z and had it up top. But aren't they still the same side lengths for all three of them? What I'm getting at here, it doesn't matter where you place it within space, as long as you understand that if Z is the angle that's between the two sides, you're going to be fine. So if it tells you specifically where the vertex angle is, you have to make sure that that's the vertex angle. If it doesn't, it's a little bit more nonchalant. ABC is an isosceles triangle. What do you, just take a guess. Take an angle side umption about where which one of those is going to be the vertex angle. B. If it doesn't tell you which one is the vertex angle, like this one does not tell you which one it is, you can always default to the second letter. If it doesn't tell you, default to the second letter, okay? So all you do then is just fill it in. A, B, C, which means those are your two sides. Okay? So if it doesn't say which one is the vertex angle, default to the middle letter. If it says which one is the vertex angle, use it. So I said it's kind of subtle, but I guess it's really not as subtle as it looks. It's pretty blatantly obvious. Okay? Meh? Meh? Okay. Quite honestly, that's about as goofy as this stuff gets. Making sure you understand the language behind it. Everything else kind of falls into place rather quickly. Okay? Let's try the equilateral. We all knew this as well. This was nothing new. We've defined this before. We were able to do that without a hassle. We all know that an equilateral triangle has all three sides the same. We also know that it's equilateral. It has all three angles the same. So if you have all three angles the same and you're a triangle, G, what do you think all three of them are going to measure? 60. That's how it works. If all three angles are going to be the same in a triangle, all you got to do is take 180 divided by 3 and you get 60. Okay? There will always be 60 degrees. And just like we said earlier, if you have the three sides that are the same, the three angles are the same, and it works going the other way. If you have all three angles that are the same, what do you think about all the sides then? They'll also be the same. It's very, very straightforward. I'd love to do proofs with these, but we don't need to. I'm sure you're heartbroken.
No.
Did you say
I'll go crying.
I have any Kleenex, but I got this paper that's on the floor. So, let me show you a little fanciness then. This crazy word. Perimeter. What does the perimeter mean? Yeah. The distance around an object, the fencing. So, if this is an equilateral triangle, and I know that one side is 15, what's the perimeter? If this is an equilateral triangle and one side is 15,
They're all 15.
correct. So what's the perimeter? Right. Just trying to make sure you guys remember what perimeter meant. Perimeter meant just add up all the sides.
15 plus 15 is 30.
Okay. We do perimeter a lot. Perimeter a lot. Hey, does your perimeter always equal 180? No. What equals 180? Yeah, the sum of the angles. You'd be surprised how many times I see people try to add up the side lengths and set them equal to 180. They're side lengths, ladies and gentlemen. The only time they equal 180 is if the perimeter is 180. That doesn't happen all the time. People, I know, right?
I wind up probably doing that, so.
So now you know not to do it, so don't do it. Okay? So let's- So I'll show you an example.
Right. I literally said I was going to concern.
X is 2. But you're not done. It asks you to find the side lengths. When you have to find the side lengths, then you just substitute back in. What's 2 plus 7? 2 times 2 plus 5. 3 times 2. Subtract 1. Does it still look like it's an isosceles triangle? There you go. Get all the algebra stuff done on here tonight. We'll worry about, we'll check the algebra tomorrow because I know we're running short on time. I was able to, the only class I was able to get 3 more done, but oh well, thank you, Internet. And we'll start worrying about proof stuff tomorrow. If you get rambunctious, you want to keep going through proofs, go for it. Spend more time on them tomorrow. Real fast. I don't know why I have to talk over you guys. I should be yelling. So I'm not going to. Don't do the last one because you don't need to. You don't have to worry about it.